All right, we are in Chapter 2, Section 3, called Solving Multi-Step Equations. This is for Integrated Math 1 or IM1. This is the exact screen that you will see when you log in as a student, with the exception of a couple pieces, because this is the teacher preview. So I don't have a due date up here at the top, and you will. And after that, you'll see the attempts, just like I do here. This is showing me I am on attempt number 1 of unlimited attempts. This means I can go in and do this assignment as many times as I would like. Number of questions, it tells me that this one has 10 questions on it. You'll have anywhere from 1 to 10 questions on your assignments. Grading policy is always best score, meaning that, whichever attempt is your best one is the one you get to keep. And partial credits enabled, meaning if you answer 1 of 10 questions, you get credit for the 1 question. This is just a reminder that we should always click the submit button once we've started an assignment. So after I click submit here, and on your screen, you will see a submit assignment button. I do not see that here because that's the other piece that the teacher preview is missing. But on yours, you will see it. And even if you've only answered 1 of 10 questions, click that submit button. Number 1, it tells us where you are, tells us what you've been working on and what your grade is for that assignment. It also will stop it from locking you out of all other assignments. If you just exit out of the screen or you click the home button here that's on your screen, then it's going to lock you out of everything. You can't do topics, you can't do home tests or quizzes or other homework assignments. You'll have to come into this one to finish. So it's very important to click that button. Click the submit button. You have unlimited attempts. You can come back in and take it again. No penalties or anything like that. So you have 3 buttons on the side here as well. So explanation will literally give you the solution to the problem you're looking at right now. So the attempt is going to be taken away. You're going to get an X on that one, and you're going to have to come back in and try it on another one. It's a very useful resource because sometimes the example is different enough that you can't quite figure out what they're asking you to do. Usually they're not that different. It's usually very, very close with the example. So the example, that's kind of a freebie there. You can work through the whole problem and look at it and say, okay, this is how we solve a multi-step equation. They even show you how to check and answer here. So they give you that guideline too. And you can say, okay, I totally understand how to do this now. I can go ahead and try to solve this problem. If you need another example, you can click here and it will give you a brand new example. You can also use the message center that will message your teacher and attach this problem to the message so we know exactly what to come help you with. All right, so let's go ahead and get started here. So we're solving multi-step equations. So one thing we want to do is focus on PEMDAS. And actually, I'm going to write this a little lower. Sorry. PEMDAS. And you need to remember that we're simplifying with PEMDAS from left to right. This is for simplifying, okay? Once I've simplified completely, I can still kind of use PEMDAS. What I do is I kind of flip around and go backwards here. And I should stop at exponents, and I can solve. But I go backwards. And I'll explain this while we're doing the problems here. So first, we're going to simplify. So let me write the problem out. 13 equals 37. All right, so 5e minus 13 equals 37. So we want to make sure this is simplified. So there's no parentheses, there's no exponents. We do have a multiplication issue here, but we can't do anything about it because I can't really multiply 5 and v. And we do have an addition-subtraction issue with minus 13, but in the simplification part, I can't do anything about it. Okay, I'm completely simplified. Now I can switch over to solving. And when we go backwards, what I want you to ask is, what is being added or subtracted to the variable? So in this case, I'm subtracting 13 from the variable here. Make sure you're subtracting the number and it's not multiplying a negative number, because I see students mix that up all the time. And this is in fact subtracting 13. So we're going to do the opposite, so that we're undoing the minus 13 on the left side here, and we're moving it to the right side. We're adding 13 to both sides because we're trying to get this v all by itself. All right, so now 37 plus 13, we get 10. and 3, 4, 5, so we get 50. So now we're moving to multiplication or division. So what's being multiplied or divided by the variable or into the variable? Well, we're multiplying by 5. I'm going to do the opposite. And I'm going to divide by 5 on both sides because that cancels. So this is what we're looking for, this cancellation. Because each time we should be getting closer and closer to v being by itself. So 5 divided by 5 becomes 1. I do not need to write 1v. That means it's by itself. 50 divided by 5 is 10. So in this case, v has to be 10. Check. Alrighty. Let's go ahead and keep moving here. Okay. Let's see. So, let me go ahead and write my problem down here. We have 157 equals 20 minus v. So in this one, again, I'm trying to get v by itself. So I want to make sure I'm simplified, and this one's pretty darn simple already. There's no parentheses, there's no exponents, there's no multiplication or division. There is only addition and subtraction. So it's a positive 20 and a minus v. So I'm adding 20, I'm subtracting v. So what is being added and subtracted to the variable, or you can say on the same side as the variable if you want to think of it that way. So we're not looking for the negative v, I'm actually looking at the 20. The 20 is being added. So I'm going to subtract the 20 from both sides like that. And I'm going to have 7 and 3 and 1 equals 20 minus 20 cancels, and I have negative v drop down. I don't want to know what negative v is. I want to know what just v is. I can see that here. So whenever you're left with a negative variable, remember that's a negative 1. So really I want to divide by negative 1 on both sides. All that does is make this negative. It just flips the sign. So instead of it being a positive 137, it's a negative 137. And it was negative over here, but two negatives make a positive. So really, you remember that you're dividing by negative 1, but what it does is it flips all the signs. And it doesn't matter in the least that this says equals v, but over here it's v equals. This is a symmetric property. It's perfectly fine to flip them around. V equals negative 137 is the same thing as negative 137 equals v. They're the exact same thing. It's just in the opposite order there. All right. So now, there we go. So now we have negative 12 equals negative 4 plus 2x. Okay, so we're just going to keep on practicing this idea. So first, simplify. Make sure I have no parentheses, no exponents. I have no multiplication or division I can do anything about. No addition or subtraction I can do anything about. So I'm going to switch over to solving. So what is being added or subtracted to the variable? So be careful. I know there's a plus 2, but that's being multiplied. It's the negative 4 that's actually being subtracted. Even though we say negative 4, it's where it is in the sentence. If it was written over here, we'd say minus 4. But because it's first, we say negative 4 plus 2x. So it just has to do with the proper way of reading the question. So I'm going to do the opposite. I'm going to add 4 to both sides. And this is their opposite integers. And you can draw, I've been drawing out number lines in quite a few of the other videos. So you can actually see, what's happening. So this is the plus direction. Here's the minus direction. And if I have 0 and negative 12 like this, and I'm adding 4, it means I'm moving toward the 0. I'm moving toward the positives. So I go 1, 2, 3, 4, and that'd be 11, 10, 9, 8. Because I have to count down towards 0 when I'm going on the negative side. So I end up with negative 8 equals 4 minus 4 cancels. And then we have 2x. So now I can deal with a multiplication or division. I'm multiplying by 2, so I'm going to divide by 2 on both sides. Negative 8 divided by 2 is negative 4. 2 divided by 2 cancels, and I have x. All right, -4. So these ones are definitely, I'm not going to say they're more difficult. There's just more steps, which makes sense. You know, they're called multi-step equations. When we were doing the single-step equations, you might have been able to very quickly see what the answer was without really having to do the math on it. You just could say, oh, I know what has to fill that in without having to do the algebra. But now we very much so need to work out the algebra in order to figure out the answers to these questions. So find the value of 9w minus 8 given the -2w minus 5 equals 5. Okay, so let's see. We want, and I believe what they want us to do is set these somewhat equal to each other. So we're going to take a look just to see exactly what they want us to do, because sometimes it might be a little bit of a different question what they're asking us to do. So we have one expression and one equation, same as what the problem has, different questions, or different problems. So first we solve the equation, -2v minus 1 equals 7 for v. So we want to solve it for v. And then adding 1 to each side, so they go through and they add 1 to each side to undo that subtraction, and then they divide by 2 on both, -2 on both sides to undo the multiplication there. So they know that v equals -4. And then they simply go and plug it into that other one. So it's 3v plus 7. Well, v is -4, so they plug it in. So that's what they want us to do here. So they want us to go through on this first one, or the second one actually, and they want us to solve it. This is an equal sign, so it's an equation. I can solve this problem. I can get it all the way down to w equals. So what's being added or subtracted on the same side as the variable, or from the variable? -5. So that's -5, right? Or -5 means the same thing. So I'm going to add 5 to both sides. -2w drops down. And we end up with 10 there. We're going to divide by -2 because that's multiplying by -2. So -2 divided by -2 is w. 10 divided by -2 is -5. Right, this is not the answer we want to type in. We want to go back and say 9w minus 8 equals, well, instead of w, we're going to have -5 here. So 9 times -5, we get -45 minus 8. So remember, I'm at -45 and I'm going 8 more negative. So I want to add these two together. So let's see, that would be 53 negative. So this is what they want us to put here. So we had to figure out what is w equal, and then we had to plug it in. All right. Okay. -7 equals 5x minus 2 divided by -4. Okay, so when we have one like this, where an entire side is being divided, what we want to do is get rid of that division first. Because otherwise, if we try to do the addition, subtraction first, and then the multiplication, division, we'll keep in mind, technically, this is what this looks like. Is like this, over 4. We're dividing both sides by that 4. So if we try to do addition and subtraction, we're going to be subtracting or adding a fraction, which is not always very fun. So we can get rid of that whole division by doing the opposite. I'm dividing this entire side by -4, so I'm going to multiply by -4 on both sides. Well, -4 times -7, 2 negatives make a positive. 7 times 4 is 28. 4 divided by 4 cancel out, right? Because -4 divided by -4 Now I have is 5x minus 2. So that's definitely the easiest way to kind of go through and get rid of that fraction piece so we can start solving this. So now I can start doing addition, subtraction, multiplication, division. So I'm subtracting 2. I'm going to add 2 to both sides. So I get 30 equals 5x, 2 minus 2 cancels. Now I'm multiplying by 5, so I'm going to divide by 5. So this gives me 6. 5 divided by 5 cancels to give me just x. And again, it doesn't matter that it says x equals 6 or 6 equals x. They mean the same thing. All right. So we have rewrite the equation below so that it does not have fractions. So this is what I was talking about earlier, where we can get rid of the fractions. So they're not actually asking us to solve it. They're asking us to practice that idea of eliminating fractions. So we say, what's the lowest common multiple for 4 and 8? Well, in this case, it would be 8, because 4 plus 4 is 8, and 8 is its first multiple of itself. So if I multiply everything by 8, then I can eliminate these fractions. So 5 times 8, that gives me 40. Plus, remember in this case, I can go 8 divided by 4, because I'm multiplying by 8 here on each piece. I'm going to write it like that so we can see it. So I'm distributing that. So I can go 8 divided by 4 is 2, and then 3 times 2 is 6. So I'm just eliminating it, and I can write this down. And now I do the same thing here. 8 divided by 8 is 1. 3 times 1 is 3. So this is the same equation, just with the fractions eliminated. So it simplifies it. And it says do not write as decimals, so it doesn't want you to just divide them. It actually wanted us to go through and do this method of eliminating fractions. Okay. So let's go to our next piece here. All right, so we're going to practice this again on this guy, because again, I think it's much easier to eliminate the fractions than try to deal with them. So 5, 2, and 3. So, and if you weren't sure what the lowest common multiple is, you could go 5, 2, 3, and just start counting. Well, 2s are easy. 2, 4, 6, 8, 10, 12, 14, 16, and it looks like we're going to have to keep going, because so far I've gotten to 10. So if we go 5, 10, 15, 20, 25, 30. But I know that the 10s match here, and then if I kept going, the 20s would match. But if I do 3s, 3, 6, 9, 12, 15. Well, I have 15 and 15, but 2 doesn't have 15 in it, right? 12 and 12 from here. But remember, they have to all 3 match. So if I keep going on this one, and I'm going to go dot, 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 I'd get to 30. And same thing on 2. If I kept going, I could get to 30. So 30 is our lowest common multiple for 5, 2, and 3. And we can actually, if we had just multiplied 5 times 2 is 10, times 3 is 30, you can also do that. It doesn't have to be the lowest common multiple, but that's definitely the most common. So there's not any reducing that's necessary, but it doesn't have to be the lowest common in order to make this work. So we're going to multiply everything by 30. Remember, that's every single thing by 30 here. So 30 divided by 5 is 6. 4 times 6 is 24. 30 divided by 2 is 15. 15 times 3 is 45. And then 30 divided by 3 is 10. I was writing that on the wrong 30. Doesn't really matter too much. So 10 times negative 4 is negative 40. So now I can start to solve this because I've eliminated the fractions. So I'm subtracting 45 on the same side as the variable. I'm going to add 45 to both sides here. And I get 24v. Negative 45 plus 45 cancel. And then negative 40 plus 45, they're opposites. I'm going to subtract. And I have more positive than negative, so it's going to be positive 5. And then I'm going to divide by 24 on each side because I'm multiplying there. So v equals 5/24. That's a 2. There's nothing I can really do about that because 5 and 24 don't reduce by anything. So I'm just going to go ahead and type this guy in. 5/24. Check. All right. 3 more problems here. Okay, so we're going back to some translations. Again, if we don't understand or don't recognize the keywords very quickly, we need to go back and study those word lists. I have a word list in ALEKS. It should be, I believe, the second link in the resources, where it's just a link to a outside website that lists all of these keywords that you need to know. So the sum of 8 times a number and 4. So the sum of means that it's going to be addition. So addition of the next couple pieces. So it says the sum of 8 times a number and 4. So the and is the separator for the two numbers. So 8 times a number. And then it tells me use b for your unknown number. So 8 times a number, which is b, plus, because that's what sum is, 4. And then I hear the word is. As soon as I hear is, that's an equal sign, 2. So 8b plus 4 equals 2. All right. Okay, so let's go ahead and erase some of this stuff here. Okay, so Miguel rented a truck for one day. There was a base fee of $16.95. So no matter what, he has to pay $16.95. That's what a base fee means. So no matter what, he's going to be paying $16.95. He doesn't have a choice there. There was an additional charge of 99 cents for each mile. Oh, okay, so for every single mile he drives, there's another 99-cent charge. And he paid a total of $158.52. They want us to decide how many miles did he drive. So sorry, this was 52. This was a really ugly 52. That's what that was, 52. All right, so there's my equation. And I wrote that as I was reading it. So you might want to read through the whole thing, kind of think about it, and then go back and read, piece at a time. Go, okay, this is his base fee. No matter what, he has to pay that. I heard each for the 99 cents. So that's telling me I'm multiplying. And I need to add those two together to get my total bill. My base fee plus my mileage. All right, so now we want to start solving this. So $16.95 is being added to the miles. So I'm going to subtract that on both sides here. We have 99 cents per mile equals at $16.95 minus $16.95 cancels out. And let's see, on the right side we have $158.52, and that's minus $16.95. So we're left with $141.50. So this is the amount of money left over just for miles. So by subtracting the $16.95 from that $158, we're taking it away so that we're ignoring that amount. We know that $16.95 goes to the base fee. But there's $141.57 here. That has to be for miles. So if each mile is 99 cents, I want to divide to know how many 99 cents occurred in here. That'll tell me how many miles he drove. So let's go divide it by 99, and we get 143. So it's a little bigger than the actual number ended up there, which makes sense because 99 cents is only 1 penny off of a full dollar. So really, it's not going to throw it off by too terribly much going, through each one because it literally is just 1 penny down. So he drove 143 miles. All right, we have one more question to do here. Ooh, all right, consecutive integers. So this does tend to throw students off a little bit. So it kind of depends on the consecutive integers they give you. So it says 3 consecutive integers. It's not saying odd or even, just consecutive. That means 1, 2, 3, 4, 5. That's consecutive when I'm counting. So I don't know where I'm starting, though, is the problem. I don't know if I'm starting at 1 or if I'm starting at 100. I mean, I wouldn't necessarily be at 100 because they add up to 81, but I don't know where I'm starting here. But it's probably not going to be 1 because 1 plus 2 plus 3 is not 81. So I'm going to just pick a letter, and a lot of time they use N when they're doing this setup. So this is where I'm starting. I'm starting at N. The next number would need to be N plus 1. So this is the next one. So here's my first number. Here's my second number because it's just the next number in the sequence. The third number would need to be what I started with plus 2 more. So this would give me enough pieces here to have all 3 terms. And I'm going to expand this a little bit so I don't have to erase. So again, 3 consecutive numbers. Here's the first one, the second one, the third one. And this will set you up every time for this type of problem. Equals 81. Now remember, this is the part that's going to change based on your problem. If it asks you for consecutive integers, you're going to set up the first part exactly the same way, but you may have a different number on the end. So now I'm going to add like terms. I have N, N, and N. That's 3N. 1 and 2. That's 3. Equals 81 in this case. So really, this is the equation I want to use for consecutive integers. This will get me the correct answer if I can plug my total in here. So I'm going to subtract 3 from both sides. 3n equals 3 minus 3 cancels. And we get 81 minus 3, and that's 78. And then I'm multiplying by 3, so I'm going to divide by 3. So n equals, divided by 3, 26. So that means we're starting at 26. Since they're consecutive integers, it should be 26, 27, and 28. And if I test that real quick and I say 26 plus 27 plus 28, I do in fact get 81. I'm going to look at the example real quick because they might have consecutive odd integers, but I don't think they're going to explain that to you. So if it's consecutive even or odd integers, you might have to look at the explanation just to make sure, because that's a little different. It means we're skip counting. So instead of it just being n plus 1, it would be n plus 2. And then I would want to go 4 more for the third one. Again, that's only if you're doing even or odd integers where you're skip counting, like 2, 4, 6, 8, 10, or 3, 5, 7, 9. Okay, those ones we're skip counting around a little bit, so they don't quite work out the same. All right, well, that was all of section 3, and I will see you in section 4.